in the long run for the sequence, that's basically checking what the data does. Does it just blows up and goes somewhere, or maybe it has a stabilization and then it has some kind of limit. So to check that, you check limit in the long run for the sequence. Now it actually requires you to know the answer for this question. Do you know? What do you think? 1, how did you know? Find the leader of the top, 9 to the n. So it's going to be a limit 9 to the n. Find the leader of the bottom. That's also 9 to the n. Others do not matter in the long run. N goes to infinity. The answer is 1. You can also see it this way. Or, those are 2 limits. The first limit is 3 over 9 to the n. And the other limit is 9 to the n over 9 to the n. This is the other way to see it if you don't understand what I just did before. But this is how we teach limits in Calculus 1 class. The leader of the polynomial, 9 to the n, that's exponential function, that's the fastest function at the top and the fastest function at the bottom. So, the second limit we already agreed gives you 1. But the first limit, 3 over 9 to the n, gives you what? 0, because exponential function blows up at the denominator. 3 over the hugest numbers, you know, gives you the smallest number, you know. That is 0. So it's still 1. From both points of view, it's still 1. Well, I would write down for you if you want. It is 0 plus 1, which is 1. So sequence converges. Sequence converges to 1. The sequence is convergent, and it converges to 1, to this capital L. Capital L is usually what we call limit L. For sequence, it's very straightforward. You just find the limit. That's it. Just remember that. For the exam, multiple choice, free response, you do this, you're fine. How about series? Series or more series? This joke is not funny, like literally second time already. So, the series will look like sum of a to the a sub n. N is from, let's do 1, to infinity. So we are working with 3 plus 9 to the n over 9 to the n. N is from 1 to infinity. That is not the same thing as a sequence. Sequence was a list. Series is a sum. So unfortunately, just because dots do have the pattern doesn't necessarily mean that the series converges. Series takes height below those dots. If the height is accumulating enough to blow up, the whole series diverges. So just the limit is not enough. This is how we can show you this idea. I did show you something like this with improper integrals. Sequence is a list of data, like so. Okay, we just figured out it has a limit. Here it is. The limit is 1 for the sequence. Actually, that's not correct. The limit for the sequence is 1. We found it. Because we connected the dots using limits of the function. But for this series, we're checking the heights below those dots. So negative, negative, positive, positive. Those heights will be added together. That's what the sums are. As you remember from improper integrals, the heights need to shrink fast enough to 0 in order to converge. If the heights keep adding forever and it's kind of a lot of them, then the series diverges. For now, I only taught you one test to how to do it, divergence test. And another test is to notice if it's geometric series. So, way one to do it is the best one, is to use divergence test. Divergence test. Divergence test does not tell you if it converges, but it tells you if it diverges. Very interesting. It's a maybe the very first logical pattern you will see in math before you take discrete math. Discrete math class in linear algebra. That's where the logic starts in. Check this out. For divergence test, I need to check the limit of this series. So we forget everything we had before. We're rewriting it again. And goes to infinity. And we're checking the tails. That's what I call them. The tails. does the tail of this series blows up or not? In order for the series to converge, the tail should go to 0. This is still not enough to converge, but at least we know it should go to 0. If the tails do not go to 0, the series definitely blows up. So let me represent this way. Must be 0. Must be 0. Divergent test is not convergent test. Very interesting and confusing idea here. If the answer is 0, the series still might blow up. Just like in improper integrals I taught you before, which is, I can actually go back, applications. Right at the end of the integrals. If the tails shrink to 0, it might be not enough for sums to be finite. If it shrinks to 0 slowly, then the series blows up. As you can see, series and integration have lots of connections. So here, this is what's the example. 1 over x goes to 0, so the limit of 1 over x indeed 0 as x approaches infinity. However, the series, this function, this integral in the series blows up because it shrinks to 0 too slowly. While 1 over x squared also goes to 0, but it goes to 0 so fast that the tails become so tiny and everything diverges to a finite number. And by everything, I mean the sums, and the sums are areas, and that's why series has connection with integration. Right? Finally, what I wanted to tell you is here. After all, if the tails do not go to 0, the series blows up. That's it, simple as that. So we're checking the tails for our series. If this answer is not 0, at least we now know that the series diverges. This is what I like to explain with the idea of the hedgehog. Let me explain you with the idea of the hedgehog. Okay, yes, I really like how you mentioned. If it's not 0, we know for sure the series blows up. If it is 0, we have to use additional tests to see if it converges. So in my culture, I was taught that we're using a hedgehog example because hedgehog is a big part of Russian-Ukrainian culture. If you read Tolstoy, the war and the peace part and whatever, you will see sometimes a hedgehog showing up. It used to be a very good present between the royalties. Like when someone was proposing, here's a hedgehog, my love, and whatever. I don't know. It was a big part of the culture. Hedgehogs, very cute, but they're a big part of the Slavic culture for some reasons. They're in the forest, in the yard, and so on. Idea was a hedgehog. If you are given an animal and you are asked, do you think this is a hedgehog? And your eyes are closed. You're holding the animal and like, okay, they asked me if this is a hedgehog. The first thing you would do, you would touch the top of it. You expect it to be pointy, right? So if it's not pointy, it's soft or fluffy, well, that's not a hedgehog. At least not a healthy one. Like, let's assume that. That's what divergence test is about. You're checking the limit. If the limit is not 0, the answer is very straightforward. The series blows up. It's not convergent. It's not a hedgehog. It's not pointy. But you're holding an animal with closed eyes. You're touching it, and it is pointy. Is it a hedgehog? Not necessary. It might be another animal with a pointed top. What other animals, pointy animals, you know? Porcupine. That's a classical answer. What else? What other animals will feel pointy? What do you say? Porcupine already said. Anything else? Be creative. The fish, right? That's a very creative one. The fish. What's the name of the fish? Which one? Puffish. Yes, I think so. So it might be the pointy fish. They might be, whatever else. What? Yeah, whatever. Anything pointy. Whatever pointy is, that might be a different animal, not necessarily a hedgehog. And that's why other tests are required. So think about this logic. Divergence test tells you if the series is divergent. But if the limit is 0, it doesn't necessarily mean it's convergent, because it might go to 0 too slow. Same as a hedgehog. If it's not pointy, it's not a hedgehog. That's it. That's what the test is about. It's not a hedgehog. But if it is pointy, you need to have additional tests to see what it is. That's kind of the idea. So check the tails. That's what I call the tails. How do the tails of the series behave? If it is 0, other tests are required. Do you understand that? If it's not 0, then that's it. The answer is there. So what was the limit again? 1. And it's not 0. By the divergence test, the series diverges. By the divergence test or divergence theorem, this series diverges or blows up, or the series is divergent, because the limit is not 0. It doesn't matter that it's 1, actually. It can be 5, -7, whatever, but it's not 0. The tails should go to 0. Let me write down. This phrase is the way I teach it. It's not kind of official way. The tails must go to 0 in order for the series to converge. But that is not enough condition to converge. But at least we know that one thing. We know at least that the hedgehog is pointy. So that's like the minimum condition, the required condition. Make sense? That's kind of how I was taught. Way 2. Way 2 is actually check 2 series. Way 2 is to see that we're working with 2 series, 3 plus 9 to the n over 9 to the n. N is from 1 to infinity, are actually 2 series. 3 over 9 to the n and 9 to the n over 9 to the n. Before we checked limits, now we're checking both series, what's happening here. The first series is actually convergent. It's a geometric series. So we have 2 series here. Let's see. The first one is 3 over 9 to the n. That is a geometric series. If you check the tails, they do go to 0, right? So tails go to 0, but that's not necessarily mean converges. So we check and recognize that is a geometric series. Geometric series. It has a common factor and a and everything, whatever you learned last time in class. A is 3. Let me write it down for you. A is 3. R is 1 over 9. 1 over 9 is less than 1 by absolute value. Thus, this geometric series converges. We even have formula converges to what? So, geometric series, actually, let me not put the equal sign. It says converges as geometric series, GS. Geometric series, very nice notation for GS. And then we check B. Sum of 9 to the n over 9 to the n is a sum of 1, as n goes from 1 to infinity, n goes from 1 to infinity. And it's a very cool question. What does the sum of 1 do? Will it converge or diverge? Very interesting. Diverge, how do you know? It doesn't go to 0 by the divergence test. Amazing. That's like the minimum required. It doesn't go to 0. And the other way is actually to see what it is. Check it out. It's 1 plus 1 plus 1 plus 1 plus infinitely many plus 1 plus 1 plus, and it's keep going. This is no way this will be a finite number. It's keep accumulating way too much. Moreover, the graph will look like so, which is pretty cool to show you. The graph will be the total graph for the total function. Something here, and then it stacks at 1, like so. Well, it's since we keep adding 1s all the time. Sequence has a limit, and it is 1, but the series does not have a limit because we infinitely many 1s, we're adding infinitely many 1s. That is the idea. So there is no way this area will be finite. What do you think about this? Questions, ideas? 2 more examples, and I also like that it's from your homework, so you can finish your homework. Again, the same idea, example 2. I give you a sub n and ask both series and sequence. 3, 1 over 3 to the n. How about that? What is going on here? 1, sequence What does sequence do? 3, 1 over 3 to the n. You just check the limit, that's it. For sequence, there's no complications, and that's why 8.1 is not such an important chapter, and that's why you notice that the homework was simple. It's not very important. Everything after 8.1 is important / hard, but it has lots of applications, so it's very interesting. You check the limit of this function in the long run. Does it have some finite answer or not? What do you think? 0, right? 2 ways of seeing it why it's 0. Some of you might figure out that, wow, those people are too smart. There's several ways to see it. Intuitively you see it, or algebraically. Algebraically you see it like this. 3 multiplied by 1 over 3 to the n. Because 1 to the n is 1, and then 3 to the n is 3 to the n. That's the same thing. I missed limit. Limit n goes to infinity. Then this function goes to 0 because denominator goes to infinity. 1 over the biggest numbers gives you the smallest number. 3 times 0 is 0. This is algebraically, you can see it. Or intuitively, you see it like this. 1 over 3 times 1 over 3 times 1 over 3 times 1 over 3 forever. Bless you. That shrinks to 0 because if you have 1/3 of pizza, that's a pretty good pizza slice. You will eat it. Now 1/3 times 1/3, that's 1 over 9. 1/9 of pizza, that's pretty small. Then 1 over 3 and 1 over 3, 1 over 3, even smaller. The more you divide pizza into slices, the less the slice is. At some point, 1 over a million, that's a very small, tiny slice. So it shrinks to 0. That's intuitive. That's called number sense. Number sense. I like the algebraic way more. So what's the answer for the sequence then? Thus, this sequence converges or diverges? That's the confusing part. So it goes to 0. Is it a divergence test or what is it? Remember, for sequence, that's just the answer. For sequence, we say it converges, and to this number we got 0, not 0, doesn't matter. It's not infinity. That's it. Good enough. For sequence, don't overthink this. For sequence, you just check the limit. The limit gave you a finite number. Let me write it down. Finite number. Whatever this number is, put it in the answer. Good. Answer. Sequence is simple. It's just list of data, nothing more. For the series, though, you have to do something more. Yes. Yeah, we're gonna do it for series. Yes, we're gonna do geometric series exactly. Very good question. Very good question. Step 2. The question here is about series, so let's write it down. Series will look like this. Sum of 3, 1 over 3 to the n, and from 1 to infinity. 1 or 0? Doesn't matter. From 1. Let's be from 1. So the question is, isn't it just geometric series? The answer is yes. Question 2, then why do we need divergence test? Divergence test, usually it's a step 0. You check the tails. Tails give you 0, no information. Move on. So if you already know geometric series, you know how to check if it's convergent or divergent. Check the R, the common factor. So you are correct. We are not required to use divergence test. That is not a requirement. But it's like the very first step. It's like when you are looking for the room for your class on campus. The very first step is to arrive to campus. That's kind of here. So we're checking divergence test to see if it even makes sense to keep working on it. If the divergence test gives you not 0, you abort the mission and says it blows up. So let me write it down. That's a good point. Let's see. A, we could check the tails. The tails, which is divergence test. Divergence test. We are checking the limit of 3, 1 over 3 to the n n goes to infinity. Just like we already agreed together, it gives you 0. So that is no info. No info, use another test. Use another test or another way. So that's the thing. Divergent test tells you when the series diverges. But if it gives you 0, then it might not be enough to claim that it is divergent or convergent. You need to use another test. And that's why it's called divergence test, not a convergence test. So the tails, they do shrink to 0. Now the question is, do they shrink to 0 fast enough to converge? And someone already pointed out, which is very smart, it does look like a geometric series. B. We recognize that it is geometric series. Geometric series blows up when R is larger than 1. So R by absolute value must be less than 1 to converge. To converge. And then it has a formula. To converge to S is A over 1 minus R, where A is the first term. That is a geometric series. Let's see. I'm working with 3 times 1 over 3 to the n. Let's write down the sum. The sum, n is from 1 to infinity. Semicolon. What is the R here? 1/3. The R is always whatever is this inside of this n power. That's the R, because it's R times R times R times R. That's the idea, the common factor. R is 1/3. By absolute value, it is less than 1. We already know it converges. It's good enough. But sometimes it will be asked convergence to what? This geometric series, GS is geometric series, converges. And it converges to S. S is a finite sum, or converges to what S? S is, well, we definitely know 1 minus R, so 1 minus 1/3. But what is my A? Let's see if it's from 0 or 1. From 1. What do you think is my A? 3. Right? Let's write it down. A is 3. Calculate the final answer. I have it here, 9 over 2. 9 over 2 converges to 9/2. So not only the tails do shrink to 0, but the divergence test. That's not enough. Then we check the geometric series. Geometric series says, okay, the common factor is less than 1 by absolute value, so we definitely can say it converges. And we even found converges to what? By the formula of geometric series. Make sense? It is not very simple, just letting you know. If you feel it's confusing, that is correct. It is not a simple chapter, and it will get more confusing after this. But there will be next chapter which will be very straightforward, so it should be fine. Yes? That's what I'm also debating. I think it will be 1 in this case, but I think in my notes it should be n starts from 0. So to be correct, I was debating a bit when I was talking. Let's change n starts from 0. And let me explain what's the difference. A is the first term. First term. So if n starts from 0, A indeed is 3. If n starts from 1, then it will be 3 times 1/3, which is 1. Very good. Good job. Let's start from 0. You can ask me, how do you know where to start? This is actually the case when I choose. That's basically the choice. So it's the first term, not just the sticking out number over there. The first term. Last example is from your homework. Example 3. That is number 9 and 10. Number 9 and 10 of 8.2. We have a series, and for the first time we will see x in it. X minus 4 plus, I think, plus 4 to the n all over 5 to the n. And goes from 0 to infinity. And what they ask you in those questions, and we will have it in the future too, find x for which the series converges. find x for which this series converges. That means, depending on x, we will have different results. It's for some x, the series blows up. For some x, the series converges. So we will have to choose wisely. And it will not be just x equals 5 or x equals 7. X can be an interval from -1 to 1 or whatever it is. So let's see how we're going to do that. The idea is we will notice that it is a geometric series. So let's rewrite it like so. Check this out. I can put it in one big parenthesis, x plus 4 over 5 to the n. N is from 0 to infinity. This is a geometric series. Geometric series has a shape a r to the n, where a is the first term. And we know when it converges, when r is less than 1 by absolute value. So my r at this point, r is x plus 4 over 5. Literally everything inside of those parentheses. This is r, the common ratio. Oh, let me write down. Geometric series, GS, geometric series. So, very interesting. You might disagree, but it's very interesting. When I put absolute value, I know this must be less than 1 in order. Let me put here. It must be less than 1 in order to converge. So we're not checking this time. We are setting it to be less than 1. We say when it's less than 1, this is the interval when the series is safe. It converges. So let's solve the inequality. That takes you back to the high school algebra when you, or I don't know, high school, middle school, when you were taught how to solve inequalities. Don't worry, I'll remind you. So if you don't remember, it's fine. When you solve this inequality, you will get the safe interval. That's what I like to call it, interval of safety. So outside of this interval, the series blows up. If it's a chemical reaction, it literally blows up. But inside of this interval, you're safe to work on. And we're going to teach you how to differentiate series, integrate series, but it's only possible in a safe interval. So let's find the safe interval. How do we solve inequalities? Let's multiply by 5. Since 5 is a positive number, we don't change inequality sign. Remember, if you multiply by -5, you'll have to change the order. So those little things. But not in this case, it's absolute value, so it's fine. Now, how to rewrite this notation? X plus 4, copy to birds. Americans call them birds. No, we don't. Nobody else does. It's inequalities. 5 to the right, minus 5 to the left. Reminding you this notation of the absolute value. Absolute value of x, that's x from minus to plus. How to solve this? Well, let's subtract 4 from all these 3 sides. It's going to be minus 5 and minus 4. X plus 4 and minus 4, that's x. And then 5 minus 4. Make sense? Reminding you how to solve inequalities. And the answer follows. X is between minus 5 and minus 4 gives you minus 9 and 1. This is the safe corridor, the safe interval. So the series, it's geometric actually, let's put geometric. Series converges on or for or at, like 4x blah blah blah, or on interval blah blah blah. On x that belongs, let's do 4 I guess. 4x that belongs to minus 9 and 1. That is some minimum knowledge we teach you right now. In the future, we're going to teach you that we actually have to check the endpoints. What's happening at minus 9? What happens at 1? But that's for the future ideas. In this case, for geometric series, it's very specific. It's very clear. It must be exactly less than 1. So we don't include endpoints. So those parentheses are not brackets. Very not too, okay, I should not say it's not too bad. What do you think, actually? I don't know. Can you do this at home? Can you do this on a test? For which x the series converge? You just recognize a geometric series, solve the inequality, give the interval. For this x from minus 9 and 1, the series will actually shrink to 0 fast enough. The sums will be finite. But if it's minus 9.5, blows up. If it's 1.5, blows up. If it's 10, blows up. If it's minus 100, blows up. So it's a safe neighborhood. We're going to call it convergence set, or interval of convergence. Literally next week, we're going to call it this way. What do you think about this? All this madness, starting with hedgehogs and porcupines. This is what we did today. Check this out. Very impressive. Where is my cute hedgehog? Divergence test. Don't forget to draw a hedgehog in your exam. That's a joke, but someone actually did before. Someone drew me a hedgehog, and I was so close to give extra credit for this. But I decided not to because everyone else will get upset. It was very close, though. On the final exam, someone gave me a hedgehog.